Welcome back everyone. So now let's talk about eye conditions today. All eye structures are contained within a bony eye socket known as bony orbit. If you take a good look at this bony orbit though, it's a pretty complicated structure. You have 7 different facial bones making up this bony socket. Within or in the middle of this socket, what you see is a small hole where your optic nerve, cranial nerve number 2, is going to pass through over the posterior aspect of this orbit. Now, this optic nerve is responsible for collecting the signals from the eyeball and then taking the signal further up to the brain, specifically the visual cortex of the occipital lobe. Remember what we discussed in the previous lectures. Eye anatomy. External eye, you have upper and lower eyelids and this nice covering of the eye known as conjunctiva. Let me actually show you how this conjunctiva is going to be extending and then covering your eye. Let's take a look at this picture over here. So this is a conjunctiva, this entire color thing. So the inner aspect of your upper and lower eyelid, and it's folded this way, coming back, and then now covering the interior aspect of your eyeball. It's extending like this. Also, you also have lacrimal gland, which is located over the upper division of the eye, and the lacrimal sac is located more close to the nose. Together, they're responsible for protecting your eye from foreign object. Now, if you ever get any kind of foreign object actually in your eye, that's when you typically kind of start to, the tear will start to come out, and then it will lubricate your eye so it can actually push that whatever the object that you got in your eye out of your system. Inner eye, as I was saying a little bit earlier, this really thin top layer that you can find over the eyeball, this really thin layer is the conjunctiva, and the layer that's right next to it, which is much thicker, looking all white, extending all the way, this structure is known as sclera. And specifically this anterior portion of the sclera, that's what you see as a white of the eye. Coming back to the front of the eye, what you see here is a really thick, clear window-ish structure known as cornea. You always have this nice thick layer of the protection to protect your eyeball. And iris is the color of your eye, right there. This is the color of your eye. So for me, this is really dark brown. For some of you, it might be blue or green. But this particular part, ileus, is responsible for creating the color of your eye. This little opening that you have in the middle, this is your pupil. So you have to have this nice opening so you can allow the lights to come in and come through the eye lens and then hit the retina. So you have to have this nice opening. You have ability to adjust the size of the pupil. Typically when you are in a dark room, a dark area, the pupil is going to dilate so you can take in as much light as possible. If you're in a really bright area, it's going to constrict, trying to limit the amount of the light. And you also have a little bit of an area between the ileus and cornea. This particular area, nice opening, is known as anterior chamber. So whenever you hear the word anterior chamber of the eye, we're talking about this space. Now this space is not just an empty space, you actually have a clear fluid filling up this area known as aqueous humor. And what you have next is a lens, nice rounded shape, transparent tissue. And if you take a little closer look at this, what you're gonna see over here, the top portion of the lens and bottom, what you're gonna see is a bunch of ligaments connecting and holding this lens right there in place, as well as the muscle. Now this ligament is known as zonu of Zinn, and this little muscle right here on each side known as ciliary body. By contracting this muscle and relaxing this ligament, or maybe sometimes vice versa, relaxing the muscle and creating nice tension over the ligament, you can actually change the size of the lens so you can specifically focus on whether that's a near object or a far object. This big orange layer that you see in the back, this represents your retina. You have ability to receive light and the retina is actually able to convert that light into signals and then further pass that information through this big nerve that you can see over here, which is your, again, optic nerve. You also have a kind of a second red looking layer right on top of the retina known as choroid. This is a pigmented vascular layer between the retina and sclera, and it's responsible for supplying blood to the outer layer of the retina. Now, this is just a kind of verbal version of what we just discussed, but one thing I'd like to add is the red eye. So I'm pretty sure maybe you have this kind of a picture of your own, maybe at some point in your life. What's really happening, I can explain with the things that we just discussed. So let's say you are about to take a picture in a really dark area, maybe if it's a nighttime or really dark room. In this situation, your pupil is going to be really dilated because it's trying to take in as much light as possible. So when you take this photo, this camera flash is going to get reflected against the choroid layer because the pupil is way dilated, and then now you're adding a lot of light to kind of overwhelm that system. So the light is going to get reflected through the choroid layer, and the choroid layer has a lot of red color to it because of the high vascularity. So that's why your eye would be looking red sometimes when you take a photo in your dark area. Now, if you use ophthalmoscope and then take a really good look at your retina, you're going to see some important stuff over there as well. Some of the spots that I definitely want you to know: optic disc, this really bright area that you see almost like in a yellowish color. This part is actually not a retina. This is a visible portion of the optic nerve. Now, as we just saw, this is a kind of entrance spot of the optic nerve, where optic nerve is connected to retina. So this also is going to be serving as a blind spot. So any light that will come in and hit this spot, you cannot detect, so you cannot see. So this is a physiological blind spot that everybody has. Also, you're going to see this nice dark area known as macula. And this center point right there where it's dark, super dark, this is known as fovea. Fovea is the site of the central vision and also responsible for color perception. And the macula, this really darkish area, you have a lot of cones in this area, which are your color receptors. So any light that is going to hit this area, you have really good focus, you really get the high resolution image of that, so you can see things really well in this area. Now, this is a picture of how your lens can actually make some adjustment to see different things from a different distance. When you're looking at a really far object, your muscle can just remain relaxed, and then your lens is going to stay nice and flat. Because the object is really far away, you do not have to reflect those lights a lot. It's not very needed. So you can just stay nice and flat to see far object. When you're looking at something very near, close to you, what you're going to have to do is your ciliary muscle will have to contract, and the ligament is going to relax, which is going to create this nice kind of round, convex shape of the lens. Now, this curved surface of the lens is going to reinforce more divergent of the rays, and you can see the near object clearly. When you start to lose the ability to control your lens shape, that's when you start to develop some vision issue. When you have perfectly working eye system, your lens, muscles, everything is working, you're probably going to have this 20/20 vision known as emmetropia, meaning that your vision is normal, you can see everything fine. When you have a lens that is too rounded and it doesn't have ability to now kind of relax and then become flat, what you're gonna be still good at is you can still see the near object fine. Remember, when you have a rounded shape lens, you can see near object really well, but just not the far object. It's gonna be looking really blurry. So this particular issue, we call that as nearsightedness or myopia. Okay, you cannot see far object very well. Opposite could happen with this issue, hyperopia or farsightedness, when your lens stay too flat. It is too flat, and then you cannot make a nice and round shape anymore. So if that's the case, you can see far object very well, no issue. But when you try to look at the near object, your vision is going to go a little bit blurry. That's hyperopia. When you have astigmatism, astigmatism, it's a little bit different issue. What you have with the astigmatism is the lens surface is really irregular. You got a little bit of kind of really random curvature here and there. So when the light would come in and hit the lens, it's gonna get reflected almost everywhere. So really anything that you see is going to be looking very blurry, whether that's near or far, it doesn't matter. Now, when your vision issue is very minor, sometimes you don't really need to do anything special. You may not need glasses, you may not need contact lens, you might still be able to function okay. Now, when you start to have a little bit more of a severe issue and then start to affect maybe your life or your function, that's when maybe further examination might be needed and maybe further correction of the vision might be needed. So, next we're going to talk about the eye exam in a little bit. So we can talk about what we're going to be looking for and what we might need to do, what some of the conditions that might be possible.